Morning, everyone. We are from Group 5 from Venus University. Today, we would like to present our research titled Comparative Analysis of Hybrid Recommendation Systems of Content-Based and Demographic Filtering Against Collaborative Baselines. Here, I am Ahmad Shauki, and I have members such as Muhammad Zaki and Atal Evan Gusef. In this research, we investigate whether a classical hybrid recommendation system can effectively solve the culture problem while maintaining the competitive recommendation accuracy. On the next slide, we have why recommendation system matter. So recommendation systems have become essential because of the streaming platform now offers thousands of movies. With so many choices, users often experience decision paralysis and have difficulty deciding what to watch. So recommendation system help users to discover content that matches their interests and improve their overall user experience. However, traditional collaborative filtering has two major limitations. The first is cultural problem, where where new user or new movies have little to no interaction at all. The second is data sparsity, where the users rate only a small number of available movies and making it difficult to identify similar users or items. Therefore, our motivation is to develop a recommendation system that approach the same remains accurate even when historical data is limited. Next is about research gap and study objective. So many recent recommendation systems rely on deep learning because of their excellent prediction accuracy. However, these models are often difficult to interpret and require high computational resource. In addition, collaborative filtering continues to struggle when user is unavailable and its performance decreases as item sparsity increases. Therefore, our study proposed an interpretable hybrid recommendation system that combines content-based filtering and demographic filtering. Our objective are to build a transparent hybrid model, guarantee prediction coverage through a fallback mechanism, and compare its performance against several collaborative filtering baselines. We hypothesize that this classical hybrid approach and effectively address the cultural problem and data sparsity while maintaining the competitive accuracy. So I will now, that's it for me. I will now hand over the presentation to my friend Jackie, who will explain our methodology and our implementation. Thank you.
So this slide illustrates the overall architecture of our proposed recommendation system. Our framework processes two types of information in parallel. The first branch applies demographic filtering, which groups users based on demographic characteristics using k-means clustering. The second branch applies content-based filtering, which recommends movie based on genre similarity. The outputs from both branches are combined using weighted hybrid integration. Finally, we evaluate the model using five-fold cross-validation with mean absolute error and coverage. Unlike any modern recommender systems, our design intentionally avoids deep neural networks to maintain transparency and interpretability. For dataset and feature engineering, we use the MovieLens 100K dataset, which contains 100,000 ratings from 943 users across 1,682 movies. For demographic filtering, we transform user information into numerical features. Age was normalized, gender was label encoded, and occupation together with zip code were one-hot encoded. These processed features were clustered using k-means with two clusters. For content-based filtering, every movie is represented by 19 binary general features. We then calculate cause and similarity between movies and generate recommendations based on similar items previously rated by user. For a hybrid recommendation model, our model combines the predictions from content-based filtering and demographic filtering using a weighted equation. Through hyperparameter tuning, we found that assigning equal weight to both methods with alpha equal to 0.5 produced the best results. To guarantee prediction coverage, we designed for tier fallback mechanism. If the primary hybrid prediction cannot be generated, the model gradually falls back to demographic averages, item averages, and finally the global dataset mean. This ensures that every user item pair always receives a recommendation. For the evaluation strategy to evaluate our model fairly, we use the predefined 5-fold splits provided by the MovieLens dataset. Each fault uses 80,000 ratings, 80,000 ratings for training and 20,000 ratings for testing. We measure two evaluation metrics. The first is mean absolute error or MAE, which measures prediction accuracy. Lower MAE indicates better performance. And second is coverage, which measures the percentage of user item pairs that successfully receive recommendations. We compared our proposed model with 4 collaborative filtering baseline using identical datasets and evaluation settings. Next, for the next slide, the slide will be explained by my crewmate Atala Evan Gusev.
Okay, thank you. So this is the baseline performance. Our initial hybrid model achieved an MAA of 0.7865 while successfully generating recommendation for every user item pair. This resulted in 100% coverage, which demonstrated that our fallback mechanism completely eliminated null predictions. Next is hyperparameter optimization. We then optimized the model by turning the number of demographic clusters and the hybrid weighting parameters. Our experiment showed that using 2 clusters and assigning equal weight between content-based and demographic filtering produced the best performance. Under this configuration, the MAA improved slightly to 0.7855. And then the comparison with baselines is that we compared our model with 4 collaborative filtering methods. Our hybrid model outperformed user-based, item-based, and demographic-based collaborative filtering in terms of prediction accuracy. Although IDBCF achieved the lowest MAA overall, our model achieved the highest coverage of 100%. While our model sacrificed a very small amount of accuracy, it guarantees recommendation for every user and is more robust in cold start situations. So, in conclusions, our hybrid recommendation system successfully addressed the limitation of traditional collaborative filtering. It achieved an MAA of 0.7855, guaranteed complete prediction coverage through a 4-filter fallback strategy, and identified the optimal parameter as K equals to 2 and alpha equals to 0.5. Overall, our results show that a transparent classical hybrid model remains a practical and effective solution for recommendation systems, especially in cold start scenarios. That's it from our team. Thank you very much.